Because, like, think about it, man. Think about it. How many people have been high enough in this realm? How many eyeballs have been high enough to get a glimpse of what we're on? Think about that. What, a few generals, couple of pilots, couple of X-plane pilots? Who's been up high enough? Like a handful. Like how many? How many people say they went to the moon? 22 people, right? Of course, they didn't go, but let's say they went high up in a rocket. 22 people? Or the ones they say are in the ISS, how many are those? And that's what, 250 miles up? Say they got a drone up there. How many people have been high enough? Think about it.
Well, remember it's 10,000. It's about $10,000 per pound, right? To get objects into space. It's very expensive. It's a very expensive endeavor. Also, people have to be specially trained. You have to have credentials. Yeah, you don't just go to space arbitrarily. You have to be a scientist of some sort. What are you going to be doing in space? Are you there for vacation? Then go on the Blue Origin. Go on the SpaceX trips. If you're going to ISS, these are these are working people. They do things. They do culturing for viruses. They're growing plants on the ISS. They are testing new technology like spectrometers and interferometers. They're doing all kinds of stuff out there. They're also building out the ISS. Well, they stopped now, but they used to be doing that, expanding it, right? It's a lot of stuff that they're doing up there. They're not just up there just for no reason. So if you want to be a part of that, you have to do the work. Get the education, get the credentials, go through the training, and so on and so forth.
Yeah, we're aware of all that. Yeah. I don't want to
Right, right.
interrupt you, but I'm saying even all those people after they've done it, how many people would you say?
How many people? Over 600 people have been up there, right?
Okay, 600 people. Yeah.
Right,
So,
right. So,
so yeah.
right. So it's hard. Science is hard. That- and that's what I try to tell people in your community. The reason why there's a lot of confusion sometimes is because it's hard. I did 6 years of college. I have a physics degree. I have a software engineering degree. I have an MIS degree. It's tough. I did experiments, research in the field. Um, and to do this it's hard. You have to do. It's not easy. It doesn't come easy. You cannot just read papers and say, oh, the earth is flat. No, you go out. You have to get out there. Like this final experiment that was done, this is celebratory. This is an opportunity where flat earthers finally have gone out in the field. I have been asking for that for so long. I run a room on Clubhouse. One of my things I always say to them is, you guys don't do any work. You just criticize us. You come here, you yell at us, you say we're stupid, or we're brainwashed, we're indoctrinated. And I say, Just do some work." So one of them did work. She went down there. She saw, we told her it's impossible that you were not going to see the 24-hour sun. I told them it was impossible. They didn't believe. But she went, she saw it, right? So they all came to the room, and I said to them, now, you see, we don't just talk to talk. It's hard. You have to, it
What
costs
is this
No,
All
topic?
no,
right,
no. Okay,
dude. Is
bro.
this a
Like, let's
What
topic?
not
is
do
this
What
like that.
topic?
what is this, dude? That's oh my gosh.
what
We
is
gotta
what,
move
Brent?
on. We're just hard moving on, dude. That's just
Yeah.
what are you even
So for
doing? You're
example,
just like making fun of random groups of people in some generalized biased way. Like what is that? Well, somebody muted him. I mean, at least let him respond. But this is just like, dude, we don't want the live stream to be that. So I don't know. Do you want to finish something or say? I don't know, dude. Do you have like a point or a topic we could get on that would be like something we could actually respond to instead of just random insults of what your biased opinion of some group of people that you think are inferior to you and you're some kind of superior master of life? It's kind of the vibe you're putting off.
We never insulted anyone. We
Yeah,
just
you're
simply
making it sound like all these people are so uninformed and unscientific and they're so clueless, and you, the
They
wonderful
don't
people,
do
came
anything.
along and picked them up. It's just rhetoric, dude.
again, during our debates, we ask questions, just like you guys ask us questions, and during those debates, we establish that they have not done a lot of the work. It's simply it. So we ask them, can you do some work, please? And then we'll
Okay, who are
come
you
to.
talking about? Who are you talking about, first of all? Who is
No,
it?
no, no. I'm not going to give specifics on that. I'm just
Okay,
telling
so
you
just
about.
what I said, generalized rhetoric aimed
No,
at
it's not
being condescending and sociopathic towards your fellow humans. That's what you're doing.
sociopathic. Why
Horrible.
would you use that kind of wording?
Horrible.
Because this is not healthy
These are
social
Don't engage.
engagement.
these
This
are
is
our friends.
sociopathic.
It's my friends. These are friends that are flat earthers. These are not enemies. These are
He's
my
talking about.
friends. So these are just friends, our people, right? And I say, hey, let's do some work, and they did work, and we were happy. We all were happy. We all were excited about that. That's simply it, brother. I'm just letting you know, right? I'm sorry that you think it's sociopathic. That was not the vibe I'm trying to give off. I'm just telling you about my experience, and I know I'm going on and on. It's tough, right? Just like science, it's hard. It's tough. That's all it is. Thank you.
Science is not hard. It's got a clear cut method that you can read and follow.
Yeah, but the reading was developed by work.
Pseudoscience is hard.
You're right about that because it doesn't make sense. Thank you. The wording for science that you guys read is from work done in the field, right? Isaac
Okay,
Newton, right?
let me jump in. Okay, I would like to apologize. I came in a little bit hot. Maybe I was a little bit harsh, but dude, could we please just maybe either put yourself on mute or have a conversation that is something actually engaging that we can engage with, somebody can respond to. You've been monologuing while kind of insulting random people that we've never known, never met, as if you have a superior position to them and they're all the dumbos that you need to come and tell them that science is hard. It's what you're doing. So I don't know, could we either shift, or did you have something productive that you wanted to say?
Uh, why would you call them? Why would you say they're dumbos? We did not. We don't refer to them as that.
All right, well, that
They're
was the
just
vibe you were saying, that they hadn't been out in the field, they didn't know all these
right.
things, and then you were coming to. Okay, what is
That's
the
different.
purpose of this? What do you expect us to get out
That
of people we don't know and some kind of scenario that you're describing? Is there anything that we can glean from this?
that's
Why
different.
are you here?
Again, real quickly, we got the education. They did not. That's not a bad thing on
Who's
them,
they?
on their part, right?
Who is they?
No,
That's what I'm
it's
saying, dude. We don't have anything to engage with. We have no idea who you're
Yeah,
talking about.
you
No
need some
idea.
Talking about
specificity,
Beth.
please.
He's talking about Beth.
Yeah, bro, come up with something, or like seriously. I mean, Gio's trying to be polite to you, but either come up with a topic or go on mute. That's it.
no. I'm very polite. I was just telling about my experience in the
Okay,
world. That's all.
just what do you want to talk about? Is
That's it.
it the
No. I was
sun?
responding. I was responding to another thing that was saying, and I was giving you my experience in the world. That's simply what I was doing. That's all, right? So let's come up with a topic. We can. Let's talk about that. The final experiment. I love to talk about that because that hits to the heart of of why we are on a sphere. Let's go.
On a sphere?
Do
Wow.
What
you
on a
think
sphere, bro?
that
What?
the final experiment proved you were on a sphere?
I wouldn't use the word proof. I would say good strong evidence.
Yeah, for a model.
So, yeah, sure. What would prove your model that you have in your head to you?
To me, right? To me,
Yeah,
the sun. Okay, the
the
sun
sun will
is
prove
the sun.
to
Hold on, wait.
you
This
what your model is.
The sun
But
is the same size from morning till night.
You're
That is
deflecting
that is
from my question, sir.
no,
You're
you ask for
deflecting
evidence. I give you
from my
evidence.
question. No, I did not ask you for evidence. I asked you, what will prove it to you that the model that you hold in your head is true?
Okay, scientists don't talk about proofs; they talk about
I'm
evidence.
not
But let's talk
I'm
about
not talking
let's.
to a scientist, I'm talking to you. Please don't deflect from my question. Do I need to repeat it again?
No, sir, because I'm very intelligent and I am a scientist. So I'm just letting you know how we speak.
I'm
So let's talk
yeah,
about
yeah,
proof.
but I'm
Let's talk about proof.
asking you a question.
Yes, yes. Well,
What will prove to you that the model you hold in your head is true?
What would prove to me is how the horizon behaves. That's good proof to me.
You have a problem.
So,
Uh,
yeah, the horizon is
it's
horizontal, sir.
Uh, which part of it?
The whole thing.
Oh, really? Okay.
Yeah.
So the reason why the sky appears to meet the ground is because the ground has curved away.
How do you
This is
know
good
that?
stuff, guys.
How do you know
okay.
that?
That's the only way you will get a horizon at only 3 miles when you can
How do you know
literally
the
see.
Wait,
horizon is
wait,
at
wait.
3 miles?
Is
Is it
that in?
always
Hold
at three
on.
miles?
Is that it? Hold on. Is that in the definition? I didn't see that in the
This is
definition.
great.
Yes, the definition of the horizon is where the sky appears to meet the ground.
Yeah,
But it
appears.
doesn't. But it doesn't have that because they curved away, does it?
Yes, absolutely, 100%.
Where does it have that part? 'Cause I didn't find that in there.
Okay, check this out. The question, the hypothesis, right? The question, the first level of the scientific method, why does the sky appear to meet the ground?
Okay.
Are you legitimately asking us
Right. So
that question?
that's the phenomenon, right? So why does the sky appears to be the ground? Okay. Now what?
No, no. You do some research, right? That's what you do. So you're like, why does the sky appear to meet the ground? I mean,
Great research. I thought we were using the scientific method.
yeah, we are. That is the next line in the scientific method. You do your research.
Yeah, you do some
Can
So
I
research.
ask you what makes you
That's
think
right.
that the
You
horizons?
do research. It's definitely right. Second step after you figure out your question, which is your absurd phenomena,
right,
is to do some research to make sure anybody has already tested his idea, check you check data. You find out more information on if anybody else has come up with any scientific experiment on this. Okay, so now we're checking. What
right.
have you checked?
And so what we've checked is exactly that. If other people have done, and other people are talking about curvature and so on, and these sort of things, right? Also, we've done some readings, and it also
Okay, can
it
you get to
reveals
something
to us
specific? What do you?
it reveals to us that there is more ground further than what my eyes can see, right?
Sorry,
Right.
guys, can I butt in for a
So
second here
so
and jump in? Can you hear me? Hi,
Yeah.
everyone. Sorry, I haven't been here for a long time, but I just want to ask you what makes you think that the horizon is 3 miles away from you at a certain distance, at a certain height? What makes you think that? What have
when
you
you
done
yeah
personally? What have you,
when
well, what have you done personally to go out and know that from a certain observational height that the horizon is at that distance?
me personally.
Yes, you
What-
personally. What have you
do-
personally done
mhm,
to know that the horizon is at a particular distance from the height that you're at?
right. So when I do the research, right, the research reveals
What research have you done?
a lot. Well, a lot of research. I've researched on Eratosthenes experiments. right?
No. What
And things.
research have you
So
personally done to know that from a set distance,
yeah,
from a
that's
set
part of the
height,
research. You're
the
reading other
horizon is at a
work, right? So here's the deal. What we've done is I have been to areas where I have planted an object at a certain distance, right? Pretty large object. It was a structure that was 10 by 12-foot structure that was 5 foot high, right? Put a flag on top of it. We travel backwards, right? From that point, we got to a position that was around 3 miles, right? When we're
Was it 3
using
miles or was
when
it
we're using
around? What do you
cameras,
mean?
when we're using
That's a speed.
cameras, we realize that not all of the object is being revealed. So this is
Okay,
this
did
is
you have
much
any
further
further
in the
advice?
experiment. This is
So,
much further in the experiment.
hold on, I want to ask you some questions. So when you did that, do you have some video footage of it?
Yes, I do.
Okay, would you like to post that video footage?
I don't
Right,
have it
because
with me. I don't have it with me.
as
But
someone,
in the interest of time, there's a lot of people here, so I'm just giving
okay.
you
Well,
right.
can I
There's
just
a
let
lot
you
of
know
people
that personally, as someone who has been out and filmed the Earth on more than 600 occasions, I can tell you that the horizon is never or extremely rarely at the distance that we're told that the horizon is at. So
here.
I've been to a
Really?
elevation of 20 foot to
Right.
a certain position, to a certain spot here where I live in South Australia. And
Hmm.
I've been there over 550 days. Right.
Hmm.
So when you say that people haven't gone out and done things, that's just completely lie. That's just a complete lie. So I now have over 550 days of filming the same area. And I'll tell you that from a 20-foot observer height, the horizon will be anywhere from 3 miles away to possibly more like 17 and even up to 30 miles away. So for you to say that the horizon is just 3 miles away from a certain height is just wrong. Go back on a different day, go back at a different time, go back 3 hours later, go back 3 hours earlier, right? The horizon is never at the same position for a constant period. It just never is. And I
Uh,
can show you 550 days. I've been out yesterday. I was out there for 6 hours, and it changed within those 6 hours. It changed within minutes, right?
uh,
So
yeah, no problem. There's always a degree of refraction that's out there in the atmosphere on a regular basis. So yes, that position will change, but it's going to be between 3 to 3.5 miles. It will never
no,
vary from that.
no,
That will be the
no, you're
range.
wrong.
That'll
You're
be it.
wrong. You're
Now,
wrong.
now, if the object
You're wrong.
is emitting light from it, right, upwards, right, you may get a further distance because of the refraction, right? But if the object is a standard object, does not have light emitting from it, and so on and so forth, that horizon is going to be between 3 to 3.5 miles. That's just a fact.
Wrong. No, you're wrong. You're absolutely wrong. So I've had a camera down to a 15 centimeter height and I've seen 15 miles away. So that means that I have a horizon that is further than 15 miles away from a 15
Impossible.
centimeter camera height, right? Because
Impossible.
otherwise I can't
Impossible.
see. Well, it's not
Impossible.
impossible because I've done it. Would you
Unless
like me to post the video?
yeah, yeah, go
I can
ahead.
post the video.
Unless the
Mhm.
area that you're looking at has an elevation, right?
No,
Yes,
no.
it's not completely flat. If it has an
So I have
elevation,
mirror
when it curves up,
observations where I'm
you
5 foot
you
above the.
you may be able to see further, but it's impossible if it is out 15 miles flat ground all the way out 15 miles, it will curve away from you for sure,
No, that's false.
100%,
So there are
unless it's
also people who have
artificially built
been.
up. If it
So
if
there
it's
are
art,
also people. So there are also people who have done 35-mile laser tests, and they've seen a laser at 35 miles away when the observer is 5 foot high and the laser's 5 foot high. The only way you could do that is if the horizon itself on that particular moment is more than 35 miles away. Now, from a 5 foot observer height, according to the globe, the horizon is meant to be less than 3 miles away. But they've seen a laser at at 35 miles. So that clearly shows that the horizon is obviously more than 35 miles away on that particular day.
Hey,
So some other people have done them at
So
28 miles across water. I've
right.
personally done mirror tests where my
Mhm.
camera was at 5 foot high
Mhm.
and the mirror was at 2 foot high from 12.6
Mhm.
miles. So that means that the horizon was further than 12.6 miles away.
No, impossible.
reality, can you please
Okay.
share?
Well, post that video. That it's impossible for that to occur. Impossible.
Yeah, I want to see the
Impossible.
15
At sea
centimeter
level,
high,
brother.
15 miles
Impossible.
far.
Sorry?
I'm asking that you share the 15 centimeter high, 15-mile long observation.
Yes.
Yeah, that's on my Twitter. I mean, I'll have to jump into my Twitter and I can post it. Right?
Definitely post that.
But
It's impossible. That's not going to happen.
Share
That's
it.
my
Please
friend.
share it.
I can put money on that. You're never going to see something 15 miles away, 5 miles, 5 feet high. Impossible. If you're a
but
5 foot
you're just wrong.
observer, impossible.
But you're just wrong.
I
Okay.
wouldn't put
Well,
money on
I
that
post
don't
the
want a
video.
uptime.
story. I want to see that. You got to show me that, dude.
Yeah,
I
look,
wouldn't put money on that uptime.
This is that
yeah,
that
I
is
wouldn't put money on
that
that
is
either,
the
dude.
equivalent. That is the equivalent to not seeing the 24-hour sun at Antarctica. It's impossible. It's
Yeah.
impossible.
See, the thing is that the reason that you think that you can't see it is that so when you have a day, so when I'm at a 20-foot observer height, right, and I have a day where I know the horizon is less than 3 miles away from me. Now, how do I know that? Because I have a specific yellow buoy that's 3.6 miles away from me. So I can tell when the horizon's closer than that buoy, and I can tell when it's further away from that buoy. Right. So I can know when the horizon is closer than 3.6 miles away from me. Now, on those days there, the angular resolution to everything at the horizon is very low. Like the angle to it, the way that I see it, I'm going to be able to see everything at that 3 miles a lot better. Now, when I know that I have the horizon at a much greater distance, so the horizon is going to be more like 12 to 15 miles away. Now everything 12 to 15 miles away, those same sailing boats that were disappearing at a horizon at 3 miles away and looking really large, those same sailing boats will be tiny because now I can see them at 15 miles away. And they look tiny now. They look really small because now they're 15 miles away. Well, that's our angular resolution. That's our Rayleigh's criterion. The reason you can't see the shoreline with your eyes or even with a camera is because of Rayleigh's criterion. But when you have a mirror, and you can get the mirror to flash, you go, holy shit, I am seeing the shoreline. I can't see the shoreline physically with my eyes, or I can't see the shoreline with a camera. But when I flash a mirror from that same location, I can see the mirror. So that's telling me that I can see the shoreline, right?
Dude, you
So
could
you're saying
potentially
that,
you could potentially shut up a lot of Globers if you share this photo, 15 centimeter high off the surface, 15 miles long observation.
yeah, I've
I'm
got
a
Show it.
Glober and
plenty
I
of
wouldn't
videos of
put
it.
money on it. I
For
mean,
real. For real.
this
That
is
is,
a
yeah.
time.
I'll put money on that. It's
I,
impossible, brother. There would have to
I,
be some artificial that surface would have to be built up, put
uptime.
on a gradient.
Are you
If it's on a
familiar with
gradient, yes.
factor in uptime?
If
Sorry?
it's on a gradient, you would see
Our
it.
ship mic
But
is low, just so you know.
No,
Sorry.
the only way you can do that is by on the day when you have a completely dead flat ocean, right? So when there's no waves, there's nothing like that. It's just flat, like as if you're on a lake, and it's just a flat lake. Obviously, when it's just flat, you see further, right? When there's waves, you don't see as far.
Okay,
no,
are you
you
gonna
Simple.
show us?
Oh yeah, well, I would have to jump over onto my Twitter
Dude, I'm eager.
and
Like, yeah,
send it.
shut me.
yeah,
Show me this.
big yes, brother. Post that. That would be that that would kill globe. I mean, 5 foot observer, 5 foot height. That's what you said, and you're seeing
I said
15
15
miles.
centimeters.
No,
15
15 centimeters.
Oh no! Sorry. 15 centimeters high off the ground, and you seeing 15 miles? That's what you said, right?
Yep.
Impossible.
So
I mean,
Impossible,
it's
brother.
Wait,
it's
Send me.
wait. What
Send you
about
the
It was
cash app.
what about a 1 foot observer height 9 miles?
What about getting the evidence? What's going on?
No,
yeah,
send me your
I'm
cash
going
app,
through my
brother.
too.
I'm gonna send you $200. Send me that. I would. I would send you $200. That is impossible. 50,
1 foot
how many
observer
centimeters?
height
Observer height. How many
at nine
centimeters? You said
miles.
15 centimeters. No. Hold on. 15 centimeters. You said, or 5 centimeters.
Yeah, no,
15.
I said
15
1 foot.
centimeters. 15 centimeters. 15 miles. That's what you said, right? Impossible. Impossible, brother.
The furthest point that I
That
could see would
is
be 14.3 miles. Yeah.
Send your money.
Uptime,
Impossible.
I'm a Glober, but I would not put money on that. Refraction can do some very strange things. Say over lakes, different temperature conditions. I like
Opium.
you.
Okay.
It's not copium. I'm saying flat earthers could. I'm supporting that
You,
side. I'm saying
you,
you could in
you,
fact potentially measure that under the right conditions.
Yeah, copium
I
can be
wouldn't put
okay.
money
For
against
no, no, no.
refraction, can you can take a picture of your own ass according to global
That's
models.
not true.
One of
You
the
guys,
conditions one of the conditions would be that it is whatever he's seeing 15 miles is at a higher elevation, right?
No, it's not. It's the shore.
It's
But
not.
the
It
problem is, right, is that at the end
so
of the day,
50.
no, I can tell you that I know that I'm seeing the shore because I can see certain parts of what's going on there. And then it's only Rayleigh's criterion that you don't actually see waves breaking on the shore. I'm not saying that I'm seeing waves breaking on the shore. That's impossible. What's the angle that you're looking at from 15 centimeters high at 15 miles away, 14.3 miles away? That angle is so infinitesimally small, you are never going to directly see the shore. But you know that you are seeing it when you have a mirror flash, right? Now, on this
Mirror.
observation, I didn't have a mirror flash, but I haven't fully posted the video of the mirror flash, but I can sort of get it up and maybe just screen record it and show, right?
So
But,
the mirror flash is also at 15 meters high.
no, the mirror flash is where I was at 5 foot.
15
I
centimeters.
had my camera at 5 foot, and the person
Right.
had the mirror at about 2 feet off the water.
Wait.
I've also
So you're 5 foot camera, and he
yep,
has 2 foot off the ground at 15
yes,
miles away. Impossible.
no, that was 12.6
Impossible.
miles away.
15.
That
No,
was 12.6
impossible.
miles away.
But okay,
He
no problem. You
posted
know
it,
what?
man. He posted it. He posted it. 44 minutes after the hour.
No, big man, that is
I mean,
not
just
a
go look at the
possibility.
video, man. Go look at the
This,
video. He
yeah,
posted it.
Or
let me look
say
at
it's
that video.
impossible first before looking at the video. That's cool.
No, it's impossible. The Earth curves away from a 5 foot observer at less than 3 miles.
Yeah, that no, it doesn't.
At sea level,
It,
less than 3 miles. So there is no way he's going to be seeing an object 15 miles
We've seen further
away.
observations in this.
With
that's just false. Yeah.
it could be, you could bring in refraction, but 15 miles for
Actually,
refraction? No.
It makes a big difference uptime. I mean, don't
refraction works more
think you're going to
for
geometry your way into understanding this.
the horizon itself is just the result of refraction. The only reason we see a horizon in the first place is because of refraction. And generally, I would say the upward bending of light, and it's going
It's
to
the
cause a
limit of
horizon.
your
Okay,
vision.
so I see,
Yeah, it is the
I
limit
see
of
this
your vision.
10.
But the reason it's the limit of your vision is because the way the light works, right? So the light is bending upwards.
Yeah. But when these
And we have
globers
upward-
look up in the sky, they think they can see forever.
Okay,
Oh yeah,
yeah,
sure.
I'm looking at this rock in your observation. Do you know how high off the surface the rock is?
What rock? Oh, the
There's
rock.
like a
It's
rock.
about which rock? You mean what the distant thing in the distance? Yeah,
Where
I've got
the
it
rock
on there.
might be
It's
in
about
relation to the,
It's about 4 meters.
that you're saying that rock is 4 meters high?
Yep. It's not a rock. It's a rock wall.
Well, I don't
What?
know
So,
if you're
That's
so from
gonna
a
15
really.
miles,
15 centimeter.
and it looks that big when it's only 15 meters high?
No, it's 4 meters high. Which rock? What do you mean? You mean the actual land?
So when
Well,
you put the highest rock on your, it says average of 2-3 meters ASL, and then the highest rock is 13 foot 4 meters ASL.
Yeah. Yeah, that's an area called Curfew Point in South Australia. You can Google it if you like. Curfew Point,
it's,
South Australia.
it's barely distinguishable. How do you know you're looking at some rock?
Because that's the only thing that's there. That's what's at the tip of that thing. Now you see where I put the little line across there, and someone's got it, and someone took a screenshot of it. You see where that line is? Where that red line? That's where the water should be. That's where the water line should be. Now, if you drop underneath that, not directly underneath it, but where it cuts down and then goes out on an angle and then starts to sort of go into a green section there, that little nose part there is 66 feet. Right? And that little nose part, that's 66 feet, that's actually 16.7 miles away. Right? So I've actually learned a little bit more about this observation since I've done it. That little
Yeah,
nose
but
section is actually 16.7 miles away. It's 66 feet, and we can still see that from a 15 centimeter camera.
well,
That's not,
unfortunately, it's too blurry, big man. That looks like clouds. What is that? Those look like
it's not
clouds to me.
clouds. It
Yeah,
can't
I
be
mean,
clouds. There's land behind there.
yeah,
See, now
that picture
you're
not
trying to-
gonna work.
now you're
It's
just
not gonna
making
work, bro.
progress.
No, it's not gonna work. You come on, no, come on. You really can't put that as evidence, brother. Come on, no. It needs to be a
Yeah,
little bit more clearer so we can see and understand, right?
yeah.
I mean, that
Have you
looks
ever
like
actually
clouds.
gone out? Have you ever actually gone
That looks
out
like
and filmed on a regular basis over the ocean?
those are clouds. It looks like clouds, like white. It looks like clouds out there to me.
Okay.
We need a little bit
So
more information on it.
what you're saying then is that at just 15 miles away, there's clouds that have dropped down when you've got a whole bunch of land that's behind there as well. At 30 miles away, there's land, and you want to say there's clouds there. Currently, at the moment, what you're doing is called coping.
Oh, really? No, listen. Clouds are at a very higher altitude. You will be able to see something at a higher altitude. Yes. You understand me?
But
That is
there's
what you're looking at.
land 30 miles behind there. Have you actually watched the video? Can you see the land? I'm pretty sure you can see the land behind there. Yeah, I can even see the land in that screenshot. See in the writing where it says 14.2 miles, 23 kilometers away from Grange? See that little bit there across, and see how there's that little line that cuts across there? That's because there's land there. So what clouds do you think are now below that land section?
But is it a video or is it a picture? It's just a photo
No,
I see
it's a
there.
video. No, but that's because someone took it. Someone did a screenshot, obviously.
Oh,
No,
right. It's a
it's
screenshot.
video.
Yeah.
So what you're saying is you didn't watch the video. You asked for the evidence, but you didn't watch it.
No, I didn't see the video.
watched
I'm only seeing a picture. I'm only seeing a photo. Where's the video?
Obviously, a couple of things up. Now it's not just
44
that.
minutes
Like
after the
I've
hour.
actually, I have now actually
Oh, here it
discovered
is.
the exact reason of
Okay.
why objects disappear behind the horizon. So I actually was going to contact you, Gio, and see if you wouldn't mind me doing a presentation at some stage, because I've got so much evidence for the exact reason of why objects disappear behind the horizon now.
No,
So when I look at this,
yeah, it's not
you're
very
saying
good.
that the rock, that it's only 4 meters high. You measured the height of the rock.
Yeah, that's what Google
You
says.
measured.
That's what Google Earth says.
So,
I'm only going by Google Earth.
Well, I can't.
that rock is on the shoreline.
Yeah, and this is just one video. I've got multiple videos of this. All right, I just haven't posted everything.
The video.
I've got thousands of hours of video. I think there's no way I could post everything, but at the moment I've worked on the exact reason of why things disappear behind the horizon. Why do they appear to disappear bottom up? And that is something that I have now definitively proven what's going on.
No,
So I'm not sure.
Yeah,
I'm not sure this looks like a rocket. I would suggest putting some kind of bright reflective target.
Yeah, you need more than that, brother. You need more.
Oh, for sure. I'm not saying that. You asked me, I showed you. That's what it is.
No, that
That's
doesn't. Yeah, that doesn't. No, brother. Come on, now.
Of course not.
It's blurry. It's blurry. It's the video. It's not something we can't really. Did you go out there and measure those rocks? these sort of things. I
Dude,
mean,
even before he even
none of that.
zooms all the way in and blurs and stops in it, if you go to 12 seconds into the video, you can see that thing clear as day. What you're talking
Right?
about,
Yeah. Yeah. It seems no, brother. No, we need more than that. We need much more than that.
But you
Because
haven't
Well,
even
yeah,
watched the video, dude.
sure.
What are
and the
you
thing
talking
Yeah,
is,
but that's
about? We
right.
need more than
the
that.
thing
What
is,
you're doing
Go
is
watch
you're
the
going to
video
cognitive
before you
dissonance right
make.
now.
Sorry, go watch the video because you haven't watched it to start with.
yeah, the video. Yeah, well, I've seen the video.
And then what I show is a comparison on a different
I've
day
seen the
where we
video.
have more like about 160 feet missing.
No, impossible. That video, it doesn't give us
Impossible.
enough information for us to
Well,
judge that is exactly what is occurring.
what
It
information do you want? What
okay.
information
So
do you want?
we need to make sure that those are rocks first of all,
Well, there's
right?
nothing else there, so you tell me what they are for starters.
So that's the first thing. We need to know that you measure the height of those rocks, right? We need to. This is an experiment that you're doing. Because like how I did my experiment with my 10 by 12, 5 foot flag above it. It is 3 foot high. 3 plus 5 is 8. Is an
Did
8 foot object that
on your
we traveled the way back. We traveled all the way back 3 miles, and the bottom of the object is starting to go. We
well,
go 4 miles. We only see the top of the flag. This is good, solid experimentation, brother. You know what you're showing
how
us
high was
here.
your how high was your
So
camera? Fourier Mirage. How high was your
right,
camera?
6 foot, 6 foot out, 6 foot, right?
So the camera was at 6 foot, and
Yeah,
then
6 foot,
so just 4 miles away, you
right,
had something that was 10 foot high, and you couldn't see it.
right. No, you can't see it.
Well, there's not 10 foot of
You're
curve
only
on
going to
6 foot
see. You will
curve
see the
height
top
at
of the
four
flag.
miles.
With the bottom, the base, but the flag was on is gone. We only see the top of the flag.
Okay, but hold on, wait a second. From a 6 foot camera height at 4 miles, there should only be about 2 feet of curve. So if you've got almost 10 feet missing, clearly it had nothing to do with
No,
curvature. You had an inferior mirage,
the base of the box is 5 feet.
and then the flag was 5 feet.
The
So
flag
that's
is no
10
three,
feet.
three
You
foot
said five.
flag. Three, no,
You said
5 foot
5.
base, 3 foot flag. We
Okay, well
have
that's still 8 feet.
8 feet.
That's still 8 feet. Go
Right.
jump on an Earth curve calculator right now, and I'm telling you that at 4 miles from 6 foot camera height, it's only going to be about 2 feet of curve, maybe less. So if
Right.
you only saw the very top part of the flag, that means that you had some pretty high refraction
Not the very
going
top.
on.
We saw the entire, like the flag. We
Can you
saw
see
the
the
flag.
screenshot?
We
Can you
saw the
go
flag.
onto the thing?
We
Sorry,
saw
can I
the
just
flag.
talk for a second? Can I just
We
can
saw
you
the
right
flag.
now? Can you right now go take a screenshot of that image and post it, please? Don't have to post the whole video. Just go take a screenshot of it and post
Oh
it.
no, I don't have it with me here. No, absolutely not. That was experiment a long time ago. So I'd have to go search. I'm just telling you about my experience.
Well, then, so what you're doing is I show you evidence, and you go, I don't accept it. But we just have to
Yeah, you need more.
accept.
You need more
We don't
than that,
trust
brother.
people.
You need
I
more
show
than
you
that.
direct evidence, and you just disregard it,
That's that.
and you show nothing, and we just have to go trust you, bro. Right? That's your evidence. Trust me. I did this. Trust me.
Trust it. No. You don't. I'm just letting you know that. You know, we need more information for your video.
Yeah, we don't
You don't
have
have to
any
trust.
information from your video. At least I have
Yeah,
a
right.
video.
No problem. No problem. No, I mean,
Brilliant.
it's just that for me, what I did, and yeah, okay, you don't have to accept it. I'm just giving you why I think that the Earth is a curve is because of my experiment that we did on measuring distant objects. So the horizon is a clear indication to me that the Earth is a curve. And
No, that's
and
false.
so the question is then why does
So what
the
is the
sky
horizon then?
why does the sky
Tell me
appear
what
to
is
me
the
the
horizon.
ground on the flat Earth? Why does the sky appear to meet the ground on a flat Earth?
I told you the horizon is a result of refraction. The reason that we have a horizon in the first place is because of refraction. And then this is why that the horizon can be at drastically different places, even from minute to minute, right? So I have another video, my pinned video on my Twitter, actually has where within a 3-hour period, you see the horizon go from 3 miles away all the way to being able to see the shoreline at that same area that I just posted, right? So that is 14.3 miles away. So within, I think it was 2 hours and 45 minutes, you watch the horizon moving and getting further and further away as you watch more and more land become visible until you can see the shoreline. So what actually happened was the horizon moved from around 3 to 3.6 miles away to 14 miles away, right? That's from a 20-foot observer height, in which the horizon is meant to be 5.5 miles on a geometrically, right? So you actually physically can watch it be videoed. It's in fast forward. I could send you the entire group of videos if you wanted to. It's obviously in fast forward, so I could take 2 hours and 45 minutes down to 7 minutes. Right, and you watch it go from an inferior mirage, the inferior mirage disappear to there to be a water line, and then watch that water line drop lower and lower and lower until it gets there. Now, the objects themselves aren't moving up and down; it's the horizon itself that's moving. I can prove this. It's so easy to prove.
Okay,
right?
so let me ask you a question. Why can't you see? Why can't that video see something 400 miles away? The Earth is flat. Why?
Why?
Yeah.
Well, that's pretty simple. Okay,
Why?
so all right, let's just take that. You watch that video, that one from 15 centimeters high. You watch that.
Mhm.
Okay, so on the day when let's just accept that we could see 14.3 miles away to the shore. Let's just say we could, right? Let's just say there was even 10 feet missing. All right. If we had a boat, let's just say one of the big ships. Okay, they're about 130 feet high. The biggest of the big ships are 130 to 150 feet high. Now, on the day when we could see 14.3 miles, and let's just say there was 10 feet missing, just for shits and giggles. Now, we would watch a ship go from where I was all the way to that land, and we would see the entire ship until it gets all the way to 14.3 miles minus 10 feet. Now, on the
What's your
next
altitude?
observation
What's your
that I
height?
showed,
What's your height that
from
you're
I'm saying
standing
from
at?
15, I'm saying from I'm talking about the video that I just showed, right?
All right. Oh, okay.
15 centimeters. From 15 centimeters. Now, on the other observation from that same video, we end up with about 160 feet hidden. So what's going on there is on that day, we would have a boat travel away from us, 130-foot tall boat, travel away from us, and when it gets to the exact same location, it's going to be about 30 feet hidden, just on a different day. Why? Because it got to the horizon and then it started disappearing at the horizon, and on the other day, there was no horizon and it didn't disappear. What happened?
Refraction.
Right.
Yeah,
So why
refraction.
can't we see 400 miles away?
Why can't you see 400 miles away?
Refraction.
No, it can't be that much refraction.
What? No, I
You-
just proved to you that we can have 160 feet hidden because of refraction over just 15 miles.
Okay, so you're
So what do
using
you think is
an
going to
arbitrary.
happen at 400 miles?
It sounds arbitrary. Okay, so why can't we see something 1,000 miles away?
Well,
Oh my God.
do you have any idea what the atmosphere is? What is the atmosphere made up of?
We know what the atmosphere. We live in the troposphere, the thickest part of the atmosphere. Yes, sir.
Oh, okay. And then, so have there ever been days where do you have any mountains near you?
Yes.
Or do you have anything kind of mountains or large hills or anything like that near you? Let's say 10, 20 miles
We're
away.
talking about sea level, brother.
Okay, yeah. I'm just asking you a question. Do you have any mountains or hills or anything that are like 10 to 20 miles away from you?
Yes.
Okay. Do you have days where you can't see them or they're very, very opaque?
Well, yeah, I mean, you have the clouds and stuff like that.
No, not the clouds. It's
I
haze.
mean, it's cloud, it's hazy, it's different things,
Okay,
right?
right.
Mhm.
So now at just only 10 to 20 miles away, you're going to have hills that are almost hazed into the background,
Mhm.
but yet you want to say that at 1,000 miles away,
Mhm.
that same haze wouldn't hide things. So at 10 to 20 miles away, because
Mhm.
I've got hills and my land
Mhm.
area that's 14 miles away, that entire land area, I go out some days and I'm like, oh, holy shit, why did I even come? I can barely even see things at 15 miles away. And the hills that are at 30 miles away, gone. Can't see them at all. 100% disappeared into the haze. Sometimes they're just completely blue. 100% blue. Can't even see it. In fact, I think 2 or 3 days ago, 100% blue. Couldn't see them at all. That's 30 miles away. But you want to say that we could see 1,000 miles away?
Mhm.
Does that make
No,
any sense?
no,
Do you, like, can you now
again,
see?
we talk about at night.
Wait,
At
wait
night,
up, wait up, wait up.
at night.
I would
Hold on.
like
At
to
night,
listen.
at night, something with very high amount of intense light, like a lighthouse. Lighthouses used in the old days, right? They're 200 feet in the air, right? They are extremely intense beams. Those ships do not see those beams until they are about 20 to 25 miles away, because that's what the curvature calculates. Why
No,
didn't
there
they
are
see the
instances
light?
where
Why didn't they see the lighthouse that's 200 feet in the air from a
well,
thousand miles out at night?
You just said it
there
was
could be
200. Now it's 400. And also, didn't you just
No,
ask
no,
a
no, no, no.
stupid
I
question?
mean, I'm
Yes.
just
And
saying.
didn't you just ask a stupid question like, why can't you see 1,000 miles away? And now he explained it, and now you're trying to redirect.
yeah, you're
No,
diverting.
his explanation is nonsense. He's talking about in the day. I'm talking about at night, high
Dude, day or
Yeah.
intensity
night,
light.
you're
You
ridiculous.
cannot see. You will not be able to see something 1,000 miles away if
Okay,
you
so
if that object
does haze?
is 6 foot in the air and you're 6 foot, you will not see it,
Of course
Okay,
not.
right?
excuse me.
Your
Can
angular
can
your angular
can you now answer
size
this?
the
So
angular
so
size of an
again,
object can only be seen by
But
0.017 degrees.
yeah, and then can you now answer this? Does haze go away because it's nighttime? Is there no
it,
atmosphere because it's nighttime?
the haze doesn't. But guess what? You don't have the light
Okay,
interference from
right.
the sun.
So therefore,
You
wait,
don't.
wait, 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 don't over talk. Just all I wanted was an answer to the question. So if haze doesn't go away because it's nighttime, that means that a light needs to penetrate through all that haze, correct? Yes or no?
Yes, right. Yes, it
Okay.
does.
So
Mhm.
if the light from a lighthouse, if during the day I can't even see the lighthouse at 20 miles away because it's completely hazed out, on those particular days, how much extra do you think that the actual light from the lighthouse is going to penetrate through that same haze?
The sunlight interference is not there at night. At night, it's going to be easier to see it through the haze, right? And
Well, not
and and number
necessarily,
and
no.
number two, it's cooler. It's cooler at night, right? So the
Okay.
haze will clear much more, and there's not haze every night.
Well, actually, the haze is at its. Well, if I rock up first thing in the morning when it's
Uh,
cool, the
right?
haze is terrible. The haze is
Yes,
insane.
every morning.
Almost, yeah, almost every morning.
Really? No, sir. Come on now. Come on,
Almost,
brother.
almost every
It's not.
morning.
It's
Would you, would
not
you
every
like to?
day. It's
Would you
not
like
every
to
day
do a
we have
live stream
haze.
with me? Would you like to do a live stream with me one day, and we can sit there for like
Okay.
8 hours, and we can just go
Well,
through day after day after day, day
you are
after
in a
day after
region.
day. You want to
You
watch
are
raw
in a
videos? We can
region.
just watch raw
No
videos.
problem. You're somewhere where you get a lot of haze, maybe more often. I'm in somewhere where we don't get a lot of haze like that. Only certain times of the year. It's clear,
I just
clear
think
to the
you
horizon,
haven't gone
right?
and looked.
So I'm just letting you know that lighthouses in the old days, that's how ships knew that they were approaching land. Why couldn't they see that lighthouse 200 miles out, 300 miles out? They had to wait until
Do
they
we
were
need
at
to explain
20,
it again?
25, 30 miles at the most away
No.
before they saw
No,
those
there are
lighthouses.
days when
Why?
sailors thought of
Why?
seeing lighthouses. I just
Why?
explained it to you.
Okay. Okay, hold on.
Yeah, okay.
Have
Would
you
you
ever
like me to?
ever been on a cruise? Have you ever been on a cruise?
No, wait. Let me
Okay,
explain it to you again because you
okay,
clearly
go ahead.
weren't listening. So, do I need to repeat an entire story again? Because it's going to get really boring and redundant for everyone. So, on the observation that I showed you, if a ship was to go all the way to the land on one day, we would see the entire ship the entire way. On the opposite day that I gave on that observation, because there's two observations on that one day, that same ship would be 100% out of view by 30 feet. The horizon is the result of refraction. The position of the horizon will determine how far you can see on any given day. When you have a horizon that's close to you, it will block things in the distance at a much greater rate. When you have a horizon that's much further away from you, then you will see things much further away. So on a day, even when those people are at 40 high, like, so they're in the crow's nest, they're up at 40 feet. They don't know whether or not that horizon is just 5 miles away or whether that horizon is 40 miles away, because it looks the same. You can never tell the difference. It looks identical. Doesn't change. It looks the same thing. It just looks like the horizon. 3 miles away, looks like the horizon. 20 miles away, looks like the horizon. Looks like it's in the same spot. Doesn't change. Looks the same. So those people, they don't know exactly how far away they are. They just see the light. You're going to tell me that they knew that they were exactly 30 miles? There are accounts where they say that they saw those things at more like 60, 80 to 100 miles, right? So it all depends on the position of the horizon that they're looking at on that day, at that moment, because the horizon changes. Sorry.
Well, the horizon can slightly adjust because of refraction. Yes, we all understand that. But again,
Not slightly. Not slightly. That's not what you're
there are some
understanding.
variations. You know, you have Pete Gaspard. You know, that guy got just enough refraction that brought up an object that was like 400 miles over, but he was also like 1,000 feet in the air, some ridiculous number like that. You understand me? But the bottom line is you're on a flat Earth, right? Not all the time you will have haze on right. So you should be able to see something as bright as lighthouses can be 100,000 lumens, right?
I just
That's an
explained.
extremely bright object. You should be able to see that object. You're on a flat Earth.
Wait,
200
we
miles is
don't
nothing.
have refraction in Atmo?
200 miles is nothing.
Let me ask you a question. Do we not have refraction in Atmo?
We have refraction in the atmosphere. Yes, we do.
Yeah, no, in a flat Earth, do we not have refraction in Atmo?
In what, sir?
He's
On a
refusing
flat
to
Earth.
understand it. He's refusing to understand anything he's told. He's
I didn't hear
dismissing
him, sir.
everything.
Relax, brother. I didn't hear him.
I'm gonna back
Okay,
out now
one
because
last
I've
time.
obviously been
Hold on.
Go ahead.
Let me say it one last time.
Say one
On
last
a
time. Go ahead.
on a flat Earth, do we have refraction and do we have an Atmo?
You mean atmosphere? Stop being silly.
Atmo.
Atmosphere. No, I didn't hear. Guys,
Atmosphere.
relax, everybody. It's okay.
Atmo
Cool.
hemisphere.
Yeah. For real. Okay. You can on in reality we have refraction and we have atmosphere. Yes.
So flat Earths have that too, right?
But flat Earth
But
has no
I
curvature.
asked you a question that's a yes or no. There's no
Oh
but.
yes, sir. Yes, sir.
Okay,
Yes,
so
yes,
we do
sir.
have it.
Yes.
So
Yes.
the
Earth is not
Atmo.
flat, but in reality, we do have refraction and atmosphere. Yes. So yes, go ahead.
On a flat Earth, we
You
have
would tell me. You would tell me
refraction
if
and
you
we
have
have
refraction. You tell me.
Atmo. So light
Do you
will
have atmosphere?
bend. Light would bend. Light would do all kinds of stuff.
Right.
And the Atmo would do a bunch of stuff too. So why would it be different?
It's going to be different on a flat Earth. Here's why: you do not have curvature. You don't have curvature. 100,000 lumens. The human eye can pick up one lumen, like a mile away. That's one. That's one. 100,000 lumens. Just imagine. So on a flat Earth, brother, at night, you should be seeing that 200 miles away.
Okay, so what
You
you're not
don't.
understanding is what So this is like how to tell people you're not actually listening or you're not understanding what's going on. Okay, so again, when I have a ship that is at 14 miles away, that ship is 130 feet high, and it goes completely out of view. It gets to only, I'd say that on that day, the horizon was well less than a mile. It was probably only like 500 or 600 meters away on that day. So that ship would get to only 500 or 600 meters away and start disappearing already. And then by the time it gets to 14 miles away, it's 100% gone. So let's say that there was a lighthouse at 140 feet high. I wouldn't see the light from that lighthouse on that day. It would be gone. The light's not going to break through. The light's not going to get past a horizon that is blocking it. Right? When the horizon is closer to you, it blocks everything in the distance at a much greater rate.
What, my
Do
friend?
you
The horizon.
understand this?
The,
The reason you
no, no, no.
don't understand this is
The,
because you've never
the
done these
horizon.
observations.
The horizon is not because of refraction, brother. It's not
False. I can prove that.
at all.
You're just wrong. You're just wrong.
No, I am 100,000% correct. Okay.
Okay, so
The horizon is not because of refraction, because again, you should be able to see an object that's 200 foot in the air that has 100,000 lumens putting out at it. You should be able to see that at a very far distance. On the flat Earth, your Earth is flat. The air is not enough to obstruct that.
you're
Okay.
literally not comprehending it.
Okay.
We're just
Here's why.
talking to a brick
The
wall
human
right
eye
now.
can see. You can see an aircraft 5 miles over your head. You can't make out the windows or anything like that. No, you can't. But you can know that's an aircraft that's 5 miles over your head. You can see that, right? If that aircraft is 5 miles out into the distance on the ground, you can't see it. You will not be able to see it.
Okay,
So
so
something's
now
going on with the
let's
ground.
go into it. Okay, so if I have a horizon, let's say I'm 20-foot observer height. I've actually filmed a ship and it was 31 miles away before it disappeared, before it was completely gone. So that shows that my horizon on that day was at least bare minimum 31 miles away. So I've actually had a horizon anywhere between 3 miles and beyond 31 miles. What's the reason for that?
For a 20-foot observer, that's
20-foot
about
observer.
5. And a 20-foot observer has a horizon of about 5.5 miles.
No.
Okay.
No, that's just
That's your
false.
horizon of 5.5 miles. Now, if the
No.
object you're looking at, if the object you're
No,
looking
I'm
at
telling you,
is,
I've had a horizon at 3 miles away and up to 30 miles away. The only reason
a
you can see an
20-foot
object at 30
observer,
miles is because the horizon is 30 miles away. And that
no,
object is still traveling straight along the thing.
no,
I don't want to hear
impossible.
your I don't want to hear your
A
like
20-foot observer is not going to have a 3 mile horizon. No, they're not.
Dude,
A 20-foot observer is
do
going to
these
be at least 5
observations.
miles.
Don't tell me what I do or don't have.
It's
All
going to
right?
be about 5 miles out, brother.
False.
Your
Well,
videos
would you like
are
to
inconclusive
drop 10
evidence.
grand on this
There's a
right
lot
now?
of data missing from your videos. A lot of
My
data.
gentleman, would you like to drop? I'll drop 100. I'll bet my house on it. You want to bet? You want to drop $500,000 on it? Drop 5 grand on it. What do you want to put on it? That we can have our horizon 3 miles away.
At a
How confident are you?
20-foot observer,
How confident are you? How confident are you?
A 20-foot
How confident
observer
are you,
horizon is
gentlemen?
about 5 miles. Right?
No,
That's
that's a
your.
geometric horizon. How confident are you?
Yeah,
Are you willing
yeah.
to drop 5K right now on the table?
We are
And
that.
I can prove it.
Hold on. The geometric
Stop
horizon is because
talking.
we're on a
Take the
sphere.
bet or
That's a
not.
geometric horizon because we're on a sphere. Yeah, because that's because that calculation is from a sphere.
Yeah, exactly. But we're not on a
Yes.
sphere. That's why the horizon wasn't at 5.5 miles. It rarely is. The only time it's ever at 5.5 miles for me is when it's in transition, moving from one point further distance. It's like a clock that's broken twice a day. You know, like a broken clock is right twice a day, right? So there's always going to be a point where the horizon will transition through that 5.5 mile mark, but it's very rarely ever staying at that point, right? So once again, you seem to be pretty confident that I could not have a horizon at more like 3 miles away from a 20-foot observer height. So
if you're
let's drop
if
some
you're
money
20
down
foot,
because I'm
listen,
telling you, you're about to lose some money.
no,
Put your
I'm
money where
telling
your
you, a
mouth
20.
is.
Listen, a
You're
20
about
foot,
well then put like
a
let's
20
put it
foot.
right now.
Hold on.
Say
A
fair.
20
Say
foot
you're
observer, a 20
Put
foot
your money where your
observer,
mouth is.
a 20
Your
foot
mouth is
observer.
running so much. Let your money talk.
Okay,
say
guys, why are we
you're
interrupting? No more interruptions. Okay, a 20 foot observer has a horizon around 5.5 to 6 miles, right? If you account for refraction and these sort of things, right? Now, it can be 3 miles if the day is very cloudy and very hazy. It can be,
false.
it can be 1 mile if it's a very,
Doesn't have
very foggy day.
doesn't have to be.
It could, as a matter of fact, it could be 100 feet if it's a very, very
Can I just
foggy
say
day.
something? That currently at the moment you're talking from incongruity. What's the word? How do you say it? It's also Dunning-Kruger because you don't actually go out on a regular basis and do observations. So you actually have no idea what you're talking about.
Oh, really?
Right?
Listen,
Because you saying that the only way I can have a 3
I've
mile.
literally been on a cruise.
So
I've been on
put your
cruises.
money,
I've been on like
You're
quite a number of
incredulous,
cruises,
bro.
your money up.
and I literally see the destination that we're
Why are you
approaching
devoting?
coming up over the horizon. Literally observed it
Yeah,
coming up
exactly. Of
over the
course,
horizon,
things come up over the
right?
horizon.
So
Yeah,
it's coming up.
they
Is
do.
as we approach it, we see the top of buildings like way out. Then we see more of the building. Then we see the shoreline. That's what we see. I've
Yeah, I know.
observed that
If
every
Geo will
single
allow
time.
me,
Every single
cool.
time.
Hold on a second. Hold on one second. If Geo will allow me at some stage, in the near future, maybe in the next few weeks, to do a presentation, I will show you exactly why that happens.
Oh, really?
There's
Okay,
no, there's
yes.
no conjecture
Please,
to it
please
now. And
ping
the
me.
only
So I want to see your horizon. I want to see why I see the top of the building first, then I see
I'll
more
show
of the
you.
building, then I see the roads, then the shoreline. I start to see more. Why? Why is that happening?
Okay. Well, I'm not going to just say it because if I just say it, describing it is no good. I would need to show it, and I'm in the process of making all the videos to prove it. And I have many, many, many time lapses that I'm currently making at the moment out
No
of ships
problem.
that I've been.
And by the way, it's not Raleigh's
If we can
criteria
do it,
because
I'd like to.
we don't look at the ground when we're trying
No
to observe
interrupting of time.
objects. When we're trying to observe objects, we're looking at the object, not the ground. So Raleigh's
Yeah.
criteria is
Yeah.
not part of this whole discussion.
I'm not talking Rayleigh's criteria. When did I say Rayleigh's criteria about what
No,
why I think?
I heard you mention it much further back.
Yeah,
You were
yeah.
talking about, right. I'm just letting you know that Raleigh's criteria is not part of it because you're not looking at the ground. We're looking at
I'm
the
not,
object, right?
if
And
you see, you're actually just proving right now that you didn't listen because what I said is that when we have a horizon that's 3 miles away and you have a ship on that horizon, let's just say you have a boat that's only like 5 or 6 meters tall, right? And that's at 3 miles away. Now, with a P1000, that's going to look relatively large still because it's only 3 miles away. But when the horizon actually moves to more like 12 to 15 miles away, that same boat is going to look tiny. Now, that's all your angular resolution. That's your Rayleigh's criterion. Now that looks tiny. I have things where I can see windsurfers way out on the horizon and they look absolutely tiny. But then on a day when the horizon is more like 3 miles away, that same windsurfer, I can zoom right in on them and they look quite large. All right.
Yeah,
So what I'm saying here, hold on. What I'm saying here is that you don't go out and do these observations and you're trying to tell me that what I observe and what I can prove with hundreds of hours of footage, right, is wrong. But the sheer fact is that I have the evidence now because I've been doing this for over 2 years. I have more than enough evidence to prove everything that I'm saying. And if you want to put some money down on it, which you don't seem to be willing to do, that you can have a horizon with no haze having nothing to do with the horizon at 3 miles away. from a 20-foot observer height. We can drop 5K right now. Let's do it. Go and take the bet.
Hold on.
So
If you're a
check this- no,
20-foot
stop. I
observer,
was trying to get on
if you're
before that.
20-foot, let me
Stop.
Let's someone else talk for a
Dude,
second.
come
Let someone
on,
else
man.
talk
I
for a
was
second.
let's
trying.
make this
No,
clear.
I was trying to get in first, bro.
Let's
No,
make
no,
this
yeah,
clear.
I mean
No,
you.
because
I
I
mean
wanted
you.
to address. I wanted to address the 1,000 miles and the lighthouse.
Yeah,
Right.
for sure. Sorry, brother. I meant for you to talk.
And so, one thing is the atmospheric scattering. I asked ChatGPT, go figure, can a human eye resolve a light source of 1,000 miles with 1 million lumens? Right? It
What?
said, 1 million, because a lighthouse can have from 10,000 lumens to 1 million lumens. So I made the strongest 1 million lumens. And he says it can't because one is the atmospheric scattering and absorption. Atmospheric
Right.
effects over long distance, light gets scattered and absorbed by atmo, especially by molecules, dust, and water vapor. At 1,000 miles, almost all light would be scattered and absorbed before reaching the observer. The other thing, resolution of the human eye. The human eye has a resolving power of approximately 1 arc minute, right? At a distance of 1,000 miles, this translates to being able to resolve objects about 1 mile wide, far larger than any single light source. So the lighthouse light has to be 1 mile wide to be able to actually resolve it.
Nice one. Did you just look that up then, or did you just type that into ChatGPT then?
Type it in ChatGPT.
It's not too bad, old chat
Oh
GPT
yeah.
sometimes.
Well, ChatGPT, you can't really rely on that because it's trying to pull information from different places.
Okay, but so
uh,
now are you going to accept now that an AI has turned around and given you a more detailed explanation of why?
Yeah, the AI is wrong. It's just trying to
Oh my God.
put together. It's trying to put together like scattered stuff. That's all it's doing.
I'm
Because
gonna back
yes,
out of this
because
conversation
guess what?
because this
Yes, you can
conversation
have
is
scattering. You can have atmospheric interference. Yes, you can. But on clear nights, you will be able to see something that has 100,000 lumens 200 miles away. You
well, you're
will
just
be
wrong.
for sure.
Then
For sure.
I just
What?
put 1 million lumens.
Put 1 million lumens
I
200
just did.
miles on, bro. And 200 miles? 200 miles? You will be able to see that for sure. 100%. 1,000 miles? What are you talking about? 1,000 miles? Definitely. The AI generator is just putting reasons why you possibly won't see it. That's all. That's what it's putting in. It's trying to put all that together.
Like I know that from the Dominican Republic, you can see El Faro from Puerto Rico, which is the highlight house, and that's 70 miles away, which the
Mhm.
curve should be about 3,000 feet. It should be
No.
under about 3,000. Yes.
What's the light? The lighthouse is 200 feet in the air.
El Faro del Faraón, that's what it's called.
Mhm.
And that thing
And it's
should
two.
be,
It's two.
and it said it should be we're doing the curvature reading. It
Mhm.
says that should be under about 3,000 feet.
What's your distance?
70 miles.
You're 70 miles away, looking at a 200 foot in the air object. And what is your observer height? You're just 6. You're just 6 foot, right?
Yep.
Right. Yeah. You won't be able to see it. 70 miles now.
Yeah, but it's actually seen.
Yeah. Now, if you yourself are also at 200 feet, of course, instantaneously.
No, not even.
If you're at 100 feet, instantaneously, you will see it. But if you're at 6 foot, no. No, no. 70 miles away, no. No. If it's pointing up in the air, you may see some twilight, but no, you're not going to see that.
Yeah, I put 300 feet, 70 miles. Target hidden height is 1,587 feet. You wouldn't be able to see it.
Your observer height is?
Even if I put 300 feet.
So you're 300 feet, 70 miles away. Obstruction would be, did you say 3,000? Let me pull up a standard calculator. I'm gonna try to.
I put obstruction. I put 300 feet, 70 miles away. Obstruction will still be 1,500 feet plus.
Did the ring go silent, or is it just me? So what we've gathered from this is that you're not willing to take a bet that the horizon can be 3 miles away from 20 feet. That's one thing we can take away. We can also take away that you actually have no idea what you're talking about when it comes to the horizon, because you haven't actually really gone out there and looked on a regular basis. All you've done is, maybe 1 or 2 observations, and then you just go by what everyone else has told you, which you can read in a book. You haven't actually gone out there on a daily basis and looked at what's happening. Whereas someone like myself, who's been out on over 550 occasions in now 2 years, just disregard what they have to say. They obviously have no idea. They've never seen anything. Well, what would they know?